guys, I will do a short video on the topic of luminescence and especially about fluorescence and phosphorescence. I'd like to start with two examples that are actually examples of phosphorescence. One thing is something that you should all know, and this is phosphorescent watch dial. I guess many of you have those. So yeah, in visible light you can't see much, but if I turn off the light, you can see that it glows in the dark. Maybe I charge it up a little with tiny flashlight. So there you go. That's one example of phosphorescence. And another quite interesting thing is something that I got from the army. We have this band and it is also phosphorescent, so you can put it, sew it on your clothes or mark your way so you find your position at night. So just to see how it works, it actually glows in the dark. It's probably hard to see on the camera, but I can also charge this up and then you see the result. Great, eh? Okay, so luminescence, especially fluorescence and phosphorescence. What is luminescence? Luminescence is basically any emission of light by a substance, and this emission is not resulting from heat, so it is basically cold light. This can be caused by numerous factors like chemical reactions, electrical energy, motions. So it's basically anything that doesn't produce heat but still produces light. So an LED is also a good example of electrical luminescence. It's therefore distinguished from incandescence, and incandescence is basically light emitted from any substance as a result of heating. So for example, a candle or fire or light bulb or whatever. So a nice example for luminescence is bioluminescence. So yeah, I have a short video of this guy, and this guy actually is the larva of a bug, and it displays bioluminescence in his tail, as you can see. And yeah, why does this guy do it? It's actually really clever. This larva feeds off termites, so it lives in the in a termite mold, and by emitting this light, he attracts his prey, so the termites fly to him, and he can simply eat them. Very clever guy. Yeah, how does this work? So we basically have light emitting pigment. This is called luciferin. That's something you can see here. And this usually reacts with oxygen. This reaction is catalyzed by an enzyme called luciferase. And of course, other cofactors are involved. Usually ATP goes in to fuel this reaction. And what do you get as a result? You get the oxidized luciferin and light energy that is emitted. So very simple way of luminescence. Yeah, so I will especially cover photoluminescence, and photoluminescence is light emission after the absorption of photons, and the time periods between these absorptions and emissions can vary. So there are basically two types. Fluorescence is photoluminescence with a short period between absorption and emission, and phosphorescence is photoluminescence with a longer time period between absorption and emission. So in fluorescence, yeah, substance has absorbed light or other electromagnetic radiation, and therefore first we have the absorption, and then we have some sort of non-reactive transition. This are across the energy states of the electrons. And then when the electrons go down from the energy state, they emit the light. And because the absorption is longer than the fluorescence, we here have a difference in the light spectrum. So higher energy light is absorbed and lower energy light is emitted. Good everyday example of this are optical brighteners. Optical brighteners are basically included in basically any detergent that you can buy in stores to wash your clothes. And the idea is that if they are white, they should shine whiter than white, basically. So these optical brighteners are small particles that absorb ultraviolet light that you can't see and emit visible light, so you can see this. And actually, in my military job, I was a commander of a research and training facility about camouflage and concealment, and we had to deal with this a lot because, yeah, soldiers were washing their clothes in regular washing machines, and this poses a problem because then the camouflage pattern doesn't reflect light in the way it should, but reflects UV light especially, and you can be seen easier. As you can see in this picture, normal camouflage uniform not washed with optical brighteners and washed with optical brighteners under UV light, you really see the difference. But of course, you also see it in everyday light because you also have UV light from the sun or something. So this poses a problem, at least for camouflage. Just a nice example how fluorescence can work. So phosphorescence is similar to fluorescence, only the transition to the low energy state is slower due to some quantum mechanical reasons. I don't want to explain this in detail. But therefore, phosphorescent materials can emit light up to a few hours, and the examples we've seen in the beginning are actually examples of phosphorescent materials. So, for example, the watch dial. What are medical applications? I want to present basically two medical applications that are somehow similar. The first is histological staining. So instead of, for example, H&E staining, we can use phosphorescent or fluorescent staining. Depends also on the microscope you use. So in this example, we have the nuclei that are stained with a blue phosphorescent dye, and then we have here in green the microtubules with phosphorescent antigens, and in red you can see actin filaments also with phosphorescent antigens, so you can make certain structures visible, and well, it looks more cool than pink and purple, eh? Another example is imaging of cancer. This has been done on a mouse. Just example, normal color example. Certain cells have been stained also with a phosphorescent antigen. So this is something you can see in the near infrared spectrum. And if you merge these images, it's really easy to see where the cancer is, and you have a higher tumor to background ratio, so it's easier to recognize basically where you need to cut, which tissue you need to remove, and which can stay there. Second example, basically the same stuff, another tumor, works similar. Okay guys, I hope you enjoyed this short video about so guys, I hope you enjoyed this short video about luminescence. I hope I illuminated some of the unclear I hope you enjoyed this short video. I hope I was able to illuminate some of the issues about luminescence. And yeah, I wish you a good night. Bye bye.